Uh, Hello, my name is Daniel, and for today's seminar, I would like to introduce the paper that talked about top
소리가
to back.
너무 끊겨.
네?
소리가 너무 끊겨요.
아, 그러신가요?
저는 괜찮은데. 혹시 다른 분들은 괜찮으신가요?
저도 안 끊겼어요.
그러면 진행하도록 할게요. So top to back is a method that describes a distributed representation of topics, and I'll go into the presentation. So first, what is a topic? Topic is a latent semantic structure in a large collection of documents. So in layman's terms, topic refers to a theme or a subject that can be summarized or summarize a body of text. So topic modeling is trying to find such topics that represent a high-level summary of the information present in the set of documents. So various traditional approaches such as latent Dirichlet allocation and probabilistic latent semantic analysis exist. However, for general use, these methods pose some downfalls. First of all, a list of custom stop word lists is somewhat required, such as common words such as the, and these words need to be removed. Obviously, this is quite simple, but if you're only looking at a list of documents that are talking about, let's say, dogs, then these two words need to also be removed as they possess no information. Next step, also another step of pre-processing, as various levels of word semantics exist, as language is not as simple as numbers, stemming and lemmatization is somewhat required as well. It tries to deal with this, but these things won't be able to capture the similarity between, let's say, big and large, as they come from two different word stems, even though they are two synonyms. And also, in order to build these models, you kind of need to know the number of topics that you're looking for, as you're specifically looking for a number of topics. However, and this is obviously throughout this whole paper, this is one of the main points, is that the paper argues that topics shouldn't be looked at as a discrete set, but it should be looked at more of a continuous space. So when you look at a topic, let's say politics and health, you can combine these two topics into healthcare. So looking at this level of granularity, you can create and separate out different topics. So the goal of the paper is to build a model that is able to find the topics without the problems of the traditional approaches. So in the paper, the author argues that he provided two main contributions. The first one is top2vec, a unsupervised learning algorithm that finds topic vectors in a semantic space of jointly embedded documents and word vectors. He argues that it automatically finds the number of topics that are relevant, which can also be hierarchically increased or decreased depending on your needs. Pre-processing is not required. And also word semantics is captured as it utilizes the semantic space that is formed by word2vec. And lastly, he provides the backgrounds of or proposes topic information gain, a novel method in evaluating topic modeling methods based on mutual information. So what is top2vec? It comes from the popular distributed representation of documents and words. Obviously, word2vec is the distributed word representations that capture synthetic and syntactic and semantic word relationships, and doc2vec extends that by adding the paragraph vectors to the learning task. While these gain popularity as they capture the semantics of word and documents, they have been mostly replaced by the pre-trained models based on transformers, but the intuition behind it is quite applicable for the current task. So he argues that top2vec utilizes doc2vec to find joint document and word semantic and embedding space It utilizes the document vector clusters found from that space to find the topic vector. And then utilizing that space again, looks at the closest word vectors as the topic words. In order to look at some backgrounds, as mentioned earlier, the model utilizes doc2vec2learn jointly embedded document and word vectors. Utilizes the model distributed bag of words, which is similar to Word2Vec skipgram model that utilizes context word to predict surrounding words in the context window. So instead of using the context word, it utilizes the document vector to predict the surrounding words in the context window. So just go through, I guess, like the general background of Word2Vec and doc2vec. Given the input word vectors and the context word vectors, the goal of the training is obviously to maximize this probability distribution by updating the input vectors. The result can be interpreted as context words pulling all similar context words toward it and pushing away all dissimilar words. For doc2vec, it replaces the input word vectors with input document vectors in the corpus. And then it does a very similar thing in order to maximize this probability distribution. So once doc2vec completes its work, you obviously end up with the semantic space. And this is an example that comes from the paper. The purple dots represent obviously the documents, and the green dots represent the word documents or word vectors. You can see that there are two clusters here. One here talking about neural network or deep learning, represented by these word vectors. And also over here, another cluster that is showing something about probability, statistics, and math. And then in the middle of it, there's data, as data is quite important for both. Obviously, this is a very simplified version of the semantic space. So after the semantic space is modeled, the model utilizes two additional steps in identifying topics. First, it utilizes uniform manifold approximation and projection for dimension reduction, as usual output of doc2vec has 300 plus dimensions. Dimensional reduction is quite important in order to run any kind of clustering algorithm on, as the initial space would be too sparse. And then utilizes hierarchical density-based spatial clustering of applications and with noise to find dense area of documents in the reduced dimensions of the semantic space. The author chose these methods according to the paper as they provided the best performance for his needs. So looking at the example space, this is what it would look like if it was all the way down reduced to 2D. But this would be a semantic space without the clustering. And then once clustering is done, you can see the different dots in the space. So after finding the clusters of documents as viewed by here, it selects the centroid of the cluster as the topic vector. And then once that topic vector is chosen, it looks at the different word vectors around the topic vector to categorize that topic of these documents. So for this example, you can see it's probably talking about something about global warming or climate change or different things like that. Before stepping into experimentation, author proposed a new evaluation metric as well, which named topic information gain. At the top, you can see the total information. Contribution of each co-occurrence between a document D and the word W to the information gain can be seen as a probability weighted amount of information here. And then utilizing only the top N words from the list of topic words, and where each document is assigned to only one topic, each topic T will have a set of N words in WT and documents DT. And the information gained about all the documents when described by their corresponding topic is given by here. Here, this term is the probability of the topic word W, which is used to calculate the expected mutual information. But as we are measuring the quantity of information gained by about each document given its corresponding topic words as a prior, this is 1 in our case, since it's already given. Therefore, the updated information is here. So for any uninformative words, such as, like I said earlier, like the stop words, the, and such, the conditional probability term in the middle reduces the magnitude of the information gain. And lastly, low values of information gain will be obtained if the topic model assigns topics to a wrong set of documents as well. The author argues that this is a good measurement for evaluating topic models, and he goes on to show it in the experimental setup. So here's the experimental setup. In order to evaluate, he utilized 2 different data sets. First one was 20 news group data set with 18,000 labeled posts. TopTopic found about 103 topics, which can be reduced with hierarchical topic reduction. And then so because it found 100, these 2 methods were trained from 10 to 100 with increments of 10 topics. On the second data set, which has a lot more posts, it found a significantly higher number of topics, but which obviously can be reduced once again, because it's too costly to go all the way up to this number of topics for these models. It still did 10 to 100 with increments of 10 topics. In order also to note, these models were initially done with just the stop words already in it, and then also did when the stop words were removed as well. So here are the results. Obviously, this is quite large. So like in order to zoom in, these are the topic words from Top2Vec for the 20 news group. And you can see how they are quite informative. Like the first one is obviously something about baseball, and the second one is obviously something about motorcycles. But you can generally see how each topic are quite different from each other. Also, that they are, when you look at each topic within itself, it has similar words or something that represents similar things. But when you look at the results,
what was PWI here?
Oh, the PWI is the term from here, the probably weighted amount of information.
Let's see. The second one, okay. Probability
Yes.
weighted amount of the information.
But this is actually this. So this is only when given this one co-occurrence of document and word. But then when you look at it from a specific topic standpoint, you have to add it all up with that the co-occurrences of document and words. So it's the topic information gain, I guess the quote unquote new metric that the author presented.
This PWI of T, you mean?
Yes. Yes.
I see. So
looking
at a high level or intuitively, if this measure is high, and then what does it indicate? Like
it indicates that it provides a quite, like, it reduces, I guess the information metric as reducing the entropy, but it provides quite a bit of information in terms of what the documents represent within that topic. So a topic is assigned to a specific, or documents are assigned to a specific topic, and those words that represent the topic are informative about the documents that are assigned to that topic.
I see. Okay, yeah.
Okay, so, but the more important thing to note here, and I think this is looking at the LDA, and this is after the stop word was removed, looking at the second, third, and the fifth examples, they are just nonsensical tokens that are assigned as topic words, which has pretty large amount of information gain. And even only looking at the first one, these all represent just names of the city or acronyms for the city. So just looking at this doesn't really mean anything in terms of, it doesn't really tell you what the topic of those documents would be. Next up is just looking at the graphs of the total information gain. And this is obviously based on the metric that he proposed, looking at only at 20 number of topics when looking at top 20 topic words. It provided more information than looking at 100 topics for the other traditional methods. And the asterisk here represents when they were built with stop words removed. And looking at top 1,000 topic words, the similarities are still there. Obviously, traditional methods perform better as with bigger number of topics. They're still, according to the metric that the author presented, is worse than TopTVEC. And here is the 2D semantic embedding.
What's the main advantage of the proposed topic modeling method? So is it like joint learning with the word and the document embedding, like word2vec
Yes.
and to-vec?
Yes.
So what was the formulation or objective function of the proposed approach that jointly learns topics, words, and the document embedding vectors? Are there any?
There's nothing new. It utilizes just the doc2vec, the setup that is already available. This is, yeah. So there's nothing novel in terms of that portion of the build or the model.
So it's a straightforward extension of the doc2vec by involving the topic as the unit of the document.
Yes.
Is it true? Really?
The only extension is that after the doc2vec learns the semantic space, the only additional portion of it is that the finding the centroid and then utilizing the topic vector and then looking at the word vectors around it to find or define the topic itself.
Okay, so basically it's learning, or we train the doc2vec model.
Yes.
That jointly embeds the documents and the words in the same embedding space.
Yes.
Right. That is the first step in the proposed approach. Although.
Yes.
Right. And then what was the next step to obtain the set of the topics?
So the next step is to reduce the dimensionality of the semantic space. And then,
why is it necessary?
Because the author argues that it has too large of a set of dimensions, and running any kind of clustering algorithm to find clusters of documents is too sparse. So that was the author's argument.
I see. Then, so they use this UMAP or HDB scan.
Yes.
To reduce the dimensionality, or is
no?
It
they used UMAP to reduce the dimensionality and then utilized HDB scan to find clusters of documents.
But in this case, yeah, as far as I know, this UMAP is mainly used for 2D embedding rather than embedding into much higher dimensional space, like over tens or hundreds of the dimensions. Yeah, I don't think this UMAP, as well as this TSNE and these kind of an embedding methods, is mainly is generally just reducing the dimensionality into just 2 or 3 for the visualization purpose. Yeah, so that is yeah.
The paper does talk about the TSNE as well, and then he just talks about how he chose UMAP as it was better performant for his needs.
So, I mean, yeah, my point is, we do not usually use this UMAP or TSNE. I mean, yeah, for like a general dimension reduction methods to obtain more semantically meaningful or like a better representations by reducing the dimensionality, because yeah, they have their own like kind of distortion, yeah, the behavior of distorting the original relationship so that the distorted pairwise relationships are revealing, can better reveal the clusters in the 2D visualized embedding space. So I thought the UMAP is also having the similar intent or goal, yeah, similar to TSNE. So it feels a little bit uncommon, at least to me, to use this UMAP to reduce, as a dimension reduction method to like several tens or hundreds of the dimensions.
Okay.
So where is this paper published?
Oh, this is not this was just available on the archive. I found it from other types of research through topic modeling research, and this wasn't necessarily published.
I see.
But it is an open source project that is somewhat actively being used.
I see. But then they have like paper style, like
Yes,
write-ups or documents, right?
exactly. Yes.
So can I ask you what was the what brought you to this topic? I mean, are you
I was looking at different ways of topic modeling with different specifically more related to how BERT is utilized for topic modeling, and how BERT is utilized for creating such embedding space for it. And then I found this paper to represent somewhat of an introduction to it, and that's why I looked at it for introducing myself into the study of it, I guess. So it's not necessarily, yeah, it's hard to say.
okay? Yeah. All right. Yeah. Sounds good. Yeah. Give me 1 second. And then once reducing the dimensionality of the document vectors as well as the word vectors, and then for those dimension reduced document vectors, we perform the clustering algorithm to obtain those document clusters. Is it correct?
Yes.
Okay. And then what's the next step?
So after that, the model finds the centroid of the clusters of documents.
Okay.
And then that centroid is represented as or picked as a topic vector.
Okay.
And then looking at the word vectors that are closest to that topic vector, that ends up being, I guess, the label for the topic vector.
I see. Interesting. And then, how can we obtain like a probability distribution of topics with respect to those keywords in our vocabulary? So do they have like clearly defined probability distribution of each topic? I mean, usually topic modeling gives the output in the form of like probability distribution of each topic in terms of
I think yes, and that's I guess that's the biggest part, or not I shouldn't say the biggest, but in terms of the introduction and the way the author argues, is that LDA and the traditional methods are centered around finding that distribution and trying to make sure that the whole point of it is making it easier to recreate the original set of documents. He says that isn't necessarily what topic modeling should be doing, and so he doesn't provide any kind of ways of finding the probability distribution of the topics.
I see. Then they just provide a ranked list of those, like the most significant words included in the topic, or represented the meaning or semantic of a particular topic.
Yes.
Okay. Right. Yeah. Sounds good. Yeah.
Okay. So looking at the LDA, and this was what I was saying, just overall, they have uninformative topic words. And then moving on to the next, I think I was here.
Yeah,
the
and
true
then
labels.
sorry, but let me ask
Mhm.
another question if that's okay.
Yeah.
So word embedding and for example, like a back-to-back is trained only using the given document corpus,
Mhm. With a
or
pre-trained.
do they use any kind of pre-trained word embedding model?
Yes, for their purposes, I believe that they had a pre-trained word embedding, and they, I don't know exactly how this specific experimental setup was done, but they did mention that it can be separately learned or can be learned together as well. But
I see. Then, yeah, I'm just curious, like, so if we utilize the pre-trained word-to-back or word embedding vectors,
mhm.
and then how can we obtain the document embedding? So in the case of doc2back, it's just training like a word embedding as well as document embedding simultaneously by using the given document corpus or the training data. But if we have a pre-trained word embedding vectors, but in that case, we don't have any document embedding yet.
Yes, and at least from, I guess this is where my understanding of it is quite short, but my understanding of it was that of training a doc2vec in the similar style of how word2vec skipgram was done is what they did in their setup.
I see.
In the way of distributed bag of words setup.
I see. So I see. So in that case, I think the word2vec is kind of frozen. So they are fixed as a kind of pre-trained vectors. And then we can maybe just additionally train the document embedding vectors. Like it can be viewed as a kind of fine-tuning approach by, yeah. So in the case of doc2back, we are adding or augmenting the input layer with additional documents one-hot vectors, right? So in that case, we are adding those additional parameters that are assigned, that are corresponding to the document embedding vectors in the input layer. And then I think we can just train those parts of the parameters while fixing the word embedding vectors. I mean, I may be wrong, but I think at least that is one kind of possible and reasonable approach.
And yes.
Okay, yeah.
Okay, so looking at the semantic embedding space reduced to 2D with UMAP for visual purposes, you can see the true labels and the topic labels that was created from top2vec align pretty well. When you talk about Middle East and Israel, or Christianity and Jesus Christ and God, different things like that. And you can also see how baseball and hockey is quite obviously close because they're sports, but then they're separate and distinct in this case as well. Here are the results from Yahoo Answer. Here they don't necessarily have any kind of unsensical tokens, but looking at more specifically LDA, you can see how these last two topics that were picked don't necessarily really mean anything. You can see how good people and various verbs that don't necessarily mean anything. So you can't really assign or understand what that set of documents actually mean.
So why do we see those stop words quite frequently in the right table? I mean,
I believe that these are not necessarily the stop words. I think these are not, because this is done after stop word removal as well. So I guess these were not chosen as stop words.
Okay. I thought would the word would the auxiliary verb. I thought that
yes.
that is falling into the category of the stop word, but I may.
It should be. And they're also here as well.
Okay.
I agree, but
Okay, sounds good.
and then just looking at the
Sorry, but I think the higher quality of the topics generated by their method, like this top to back, this kind of method. I mean, the reason why this method shows better, higher quality topics is because, it may be because they are utilizing the pre-trained word embedding, I guess. Because usually in the case of topic modeling, including the LDA, they are just utilizing the term document matrix or the bag of words representation of just given the document corpus, right?
Yes, and that kind of like is at the end of the whole document as well, or I guess the presentation as well, because I think the ending result of or the presentation or I guess this presentation is more about how BERT is being applied as well in this space, in terms of stepping away from that bag of words representation and then going into more of contextualized word embedding space.
Okay, yeah.
Okay.
Okay, thanks.
So, and this is, I don't necessarily have to go too much into detail here. This is another set of results where their model does better on their evaluation. And then here is also semantic embedding space for the Yahoo answers, which aligns really well again. And this next step, or I guess the next slide is, before going into discussions, I just wanted to kind of like find or talk about another example that I found utilizing Top2Vec for a simple hotel review task. The whole implementation is available online and is quite short in terms of the implementation. And it is really simple in terms of how to utilize it. So in a couple lines of code, the results are available. So here's another example semantic space that could come. Here, the blue dots would be your reviews and the green dots are word vectors. And the top 3 topics from the hotel reviews, you can kind of see how the first one is talking about maybe the bathrooms. And then the second one talks about how they're usually small or smaller than expected or things like that. And then the last topic is more specified about the parking or how it was inconvenient or different things like that. I think the important thing to note here, and that the biggest takeaway that I had from this was that building this was extremely easy. It looked extremely easy. It's really easy to use. So in terms of value, and how like the output of it is also quite intuitive and informative, I think there's a pretty good value in terms of how this can be utilized for, I guess, non-trained users of artificial intelligence or deep learning. So going into the last slide, here's the discussion of the paper.
Sorry, but how do they encode the font size in this word cloud?
Oh, I think the word cloud is dependent on how, like the biggest one being, I guess, the biggest topic or the biggest word being the closest to the topic. So if you have the topic vector, the topic word that is the closest is represented.
Right. Intuitively, the closest word is encoded as a larger font size.
Is my assumption. I'm not 100% sure in terms of how they generated these, but yes.
I see. They didn't provide any details about it. Yeah.
No.
Okay.
No. Okay. But the implementation is online, so maybe I could actually go into it and find it as well. It doesn't seem too hard to find, but I didn't really look at it that specifically because this isn't part of the paper. This is just some other implementation.
All right. Yeah.
So here's, I guess, the discussion from the results. I think the author provided enough evidence to show that Top2Vec finds intuitive and informative topic vectors in a semantic space of jointly embedded documents and word vectors. It obviously has several qualitative advantages over traditional topic modeling methods where you don't necessarily have to remove stop words or any kind of pre-processing with stemming or lemmatization. Also, they provided the metric of topic information gain, which they believe is a valuable metric for evaluating topic modeling algorithms. and it outperformed other traditional topic modeling methods in this metric. I guess the biggest thing to note is that it would be more interesting to see how it compares to other maybe state-of-the-art algorithms, or maybe looking at different metrics other than the metric that they proposed. But for the purposes of what they're trying to get across, I think this is, I guess, what they believed was enough. And I think the main takeaway for me was that the topics should not be looked at as a discrete label, but rather a continuous space. And various other tools are built on top of this notion, building a semantic space for topics, such as utilizing BERT to build embeddings. So one of the examples that I found online was with BERT, named BERT topic. They utilize BERT to generate embeddings of documents. And in this example as well, they go through the same dimensionality reduction method, utilizing UMAP, and then also utilizing the same clustering method. And this groups the documents together, and then running through some way of picking out the topic from the set of documents. So obviously, in this case, it's not similar to top2vec, where you have word vectors close by. Here, the author decided to use TF-IDF score, looking at the cluster as a whole, as a single document, and then that allowed them to pick out the important words. And that implementation is also available as open source. So that's where I actually started to look into this. And then lastly, there are other papers that are replacing bag of words representations with pre-trained contextualized embeddings that are published in many conferences. Papers that I saw was cross-lingual contextualized topic models with zero-shot learning, which was accepted at EACL 2021 recently. And that paper shows how this can be extended into covering multilingual support. So their model relies on language-independent representations to generate topic distribution, which allows cross-lingual support. So in general, overall, it seems like the topic modeling task is one of, I guess, the latest ones, or latest natural language processing practices to apply pre-trained transformer models. And the paper seemed to do a good job of introducing an idea to that extent. And hopefully this is something that is interesting for others. That is it. Any other questions?
So what do you mean by like contextualizing the topic modeling? So basically the topic is maybe, it is defined as the set of those keywords. And those keywords are typically, just unigrams, where each unigram word is conveying like a fixed independent meaning, right? But the main point of this BERT or these contextualized word representation is to represent the same word differently depending on their context, right?
Yes.
I'm not sure how that kind of notion is combined with the topic modeling.
Well, I did read the paper, but I didn't completely understand it yet, as far as the one that I mentioned earlier, with the one that was accepted to EACL. But I think that would be, I guess, an interesting paper to kind of like understand that portion of it.
So you mean the EACL paper is that cross-lingual contextualized topic models, right?
Yes.
And
yes.
Does there exist another one called the BERT topic?
BERT topic is not a paper, but it's another, I guess, open source project that somebody just created based on top2vec, and he wanted to utilize BERT instead of utilizing doc2vec as creating embedding space. So that's another available project that shows results.
Okay, yeah, thanks.
오케이.
Any other questions?
It is quite
Right.
drained from.
I guess
그
so.
오늘 나온 그 저거가 오픈
네.
소스 뭐 그런 거잖아요. 어떻게 보면은
네.
네네.
오픈 소스 연구라고 해야 되나? 저런 프로젝트 같은 거는 좀 어떻게 뭐 피어 리뷰 같은 거를 뭐 받아가지고 그 프로젝트 하는 사람이 뭐 발전시키고 개선하고 뭐 그런 게 있어요.
그런 거는 보이지는 않았는데 이런 프로젝트들을 이제 써보는 사람들은 꽤 많아 보이는 것 같더라고요. 그래서 그거에 대한 네네, 그거에 대한 리뷰라 그래야 되나? 이제 자기가 써보고 어땠다라는 거는 많이 있더라고요.
깃허브에 스타 막 1000개 막 이렇게 있던 것 같더라고요.
1000개면 얼마나 많은 거예요?
일반인은 받을 수가 없죠.
그렇군요.
네. 그러면 여기까지 하도록 하겠습니다.
네, 수고하셨습니다.